we're going to go over the goals of the SambaTune tool, go over the performance profiling methodology, which is a documentation review, the SambaTune usage, and a brief demo. Try to get all that in 30 minutes. Right? So if I talk fast, tell me to slow down. So basically the goal is to provide you all with a tool that you can take some action to improve your models. Now, there are going to be some aspects that we're going to cover that are going to come out of this, that your action, if your performance is in a certain area, is to contact SambaNova System Support so we can assist you with it. So there's going to be some things that come out of this that you'll be able to take action on your own, and there's some things you'll be able to take action with our assistance, okay? All right, so let's go over the performance profiling methodology. Like I said, instead of going through and just copying the entire slides from the documentation, we're just going to go out and visit the documentation. So I'm going to go ahead and stop my share and share my other screen for a second. Okay. All right. So at docs.sambanova.ai, we have our documentation. SambaTune documentation is located right here, pretty evident. We're going to go through the starting with SambaTune. Right now we're going to skip this other stuff and just go over the workflow overview. Let me get this little slide bar out of the way. There we go. All right. So the top level tuning process that we do is when we go through and run, you want to make sure you run with a sufficient number of iterations. So if you're only running like 1 or 2 iterations, you're probably not going to get as good of a diagnostic analysis of it. More often than not, we want to do at least 10 times. Now we understand that if this is a large, huge, model that, one iteration takes something like 3 or 4 days. Okay, yeah, we understand that you're probably not going to run it for 10 iterations while getting your data. And then once you go through, you're going to go through, and the first thing you're going to check is, how much are you host bound? So in an ideal world, in a perfect model, you want, the bulk of your work to be going onto the RDU. You don't want it to be done by the host. So, we have these accelerators there for a reason. So obviously we want to try and drive the percentage of operation as much as possible to the RDU. And we'll go over what to check for some of the host bound stuff here momentarily. Once you've gone through and I've cleaned up my Python code, I've cleaned up my tensors, various other different things, I'm no longer host bound right now. Now I still seem to be kind of slow to what I expect, and we're going to go through and we're going to look for latency. So you go into your reports and go through and try to find your largest sections with latency. So basically, as we go through and we lay out a graph, depending, on the model, some models are quite simple and may only have anywhere from 2 sections to 3 sections. Some are more complex. You could have, I've seen upwards of 35, 40, 60 sections of a model. So, so obviously with those larger, more complex ones, it gets real interesting to go ahead and drill down, okay, where am I spending, most of my time in this large complex model? Let's see if we can optimize that section, or it could very well be that that's just the part of the model that takes that amount of time. And those are the types of decisions that you can interact with SambaNova System Support, and we can help you in that analysis. Then once you go through, you make some changes, and you can go through and you can run the reports again. Let's go ahead and look at a little bit of the optimizing host-bound models, because this is the part that typically you can tend to yourself, all right? You don't really need SambaNova's interaction to do that. So, so we're gonna look at conversion function bounds. So you're gonna go through and go into and check your tensor tab, and you're going to go through and look and see with your tensor types, am I doing a lot of conversions? Am I doing a lot of, say, data type conversions from, BF16 to FP32? Obviously, the more of those types of conversions that you wind up doing, the less performing that you're going to be on the host side calculation, okay? You're also going to look and see, okay, am I transferring tensors back and forth to the host a lot. Like I have, you know, we've seen this in the past precisely, where they're during the actual model execution in the middle of the epic, it will actually go through and they like, oh, I have all these custom calculations I like to do over on my host. So periodically in throughout the model code, I'm going to go ahead and I'm going to transfer some of my tensor stuff back out to the host, do these calculations so I can have a pretty little report. And then we're going to move back in and do some more work on there. Well, obviously, every time you're transferring those tensors back and forth between the host and the RDU, you're going to consume a lot of performance, right? And then ultimately, if you look at, you can look at your Pi instrument data. So let's say you go through and you find that you're just consuming a lot of CPU at the host level, and it's some Python function, you know, that's causing the problem. Pi instrument can obviously give you your stack. We also you can also use the C profile module of Python. So when it comes to debugging the actual Python of it all on the actual host, it's the same tools that you would use on any other Python on any other x86 system. Okay. Other tools that you can use are things like the Linux perf utility if you want to really get drilled down and try to find out, okay, how many of these particular function calls am I taking, things of that nature. That's the type of stuff that you can do. All right. Now we're going to talk a little bit about section latencies before we dive back into the PowerPoint. So what you're going to do is you're going to go through and look at, say, your DDR write and read portions of the graph breakdown in the UI. And you can see here, it's like, is the DDR bandwidth 90% of the upper limit? And our upper limit is roughly 100 gigabytes per second, okay? That's a rough estimate. Obviously, it's sometimes a little higher, sometimes a little lower, but that's a good sort of rule of thumb. So you look and say, okay, am I completely, if I'm DDR bandwidth bound, that's just is what it is. You just need to make sure you keep that pipe, stuffed full of data, so it can go through and churn and processing. There are things that we could do in house, like maybe there's portions of that could be manually split into separate sections, but that's where you would require SambaNova intervention in order to do those types of sort of handcrafting of the model layout and the path and the graph layout.
Be a quick. Can you enlarge the?
Yeah. Let me see here. Yep. How's that?
Yep. I think that's...
Sorry, I'll be actually showing you the real UI in just a moment. This is just a section out of the docs.
Thanks.
Okay, cool. All righty, I'm going to go ahead and stop this share, and then we're going to go ahead and go back to the slides for a moment. Here we go. All right, so that's just a little bit about our sort of top-down methodology. Go through profile it, get as much stuff as you can on the RDU instead of on the host. If you are host bound, use standard host side tools to tune and correct the Python. Get out of bad habits as far as constantly casting back and forth between data types, constantly transferring tensors back and forth between the host and the RDU. And 9 times out of 10, that will really get you the performance that you need out of most of your models. Then when you get into sort of handcrafting stuff on the RDU, engage SambaNova system support, and we can assist you taking you sort of down the next rabbit hole. Okay. All right, let's go ahead and take a little bit about like how you generate this stuff. So let's go ahead and look at the SambaTune usage. One thing that the SambaTune tool wants is an environment variable called dump root. All right. So just for the, for these particular tests that I've done here, or the samples that I've run here, I just use my, current working directory as my dump root, but you can specify a specific dump root where you want these things to go. Typically in most environments, it is going to be an NFS, like your home directory and NFS shared directory that you can then actually look at these reports either on your, on the actual host itself, or you can actually look at it, look at them on your workstation. It could be currently right now, you can look at them on a Linux workstation, or you can look at them on Mac. Windows is on the roadmap. All right, so it's basically, so you come through, you run SambaTune, pass your artifact root, and you'll notice here that, I just went ahead and just hit the help thing just so I could get this error message on purpose. The main thing that SambaTune requires is a YAML file. The YAML file will basically tell you, this is the application that I'm running. These are the parameters that I'm going to pass in. These are the, various array of options that I'm going to go ahead and utilize. So let's go ahead and look at some samples of these YAML files. Just so you know that when you install in 1.16 and above, when you install the SambaTune, there is actually under opt SambaFlow SambaTune, there are actually sample configs, and this is actually just one of the sample configs that are out there. But we actually do provide, I think it was 8 sample configurations for you to look at, to then, you can look at it and then say, okay, I'm going to leverage this and create a YAML file for my model. If you have any problems creating that YAML file, obviously feel free to reach out to us and we will assist. All right. So here, obviously, the main ones here are your app, your model args, your compile args, and your run args. All right. Pretty self-explanatory. So, we have our batch, our mini batch, in and out features for this linear net model. The number of iterations, more often than not, we're just going to run it, for 100 iterations. Once again, if one iteration of your model takes 5 days, we don't expect you to run it 100 iterations. Obviously use your discretion there. And then you'll see that these environment variables that you'll see frequently, and basically this is a pull busy wait. And you can tell it whether you want it to either spin or sleep when waiting on the direct memory access or the FSM, in which case we typically want it to spin. We're not stressing out the x86 side of our hardware. So, having it sit there, having your code that's running, the bits of the code that's running on the host to sit there and go to sleep versus spin, waiting for, whatever it's waiting to get back from the RDUs, it makes more sense to spin. All right, this one is a little bit of an eye chart, and I do apologize for that. So I'm just going to talk through it. You will get the slide. It's just the only way that I could fit it all in there. So this is an example of a compare config. So here it is the exact same thing, just with 2 separate entries in there, except here I'm using my end features of 5120 and 512, 2560 and 256. So you can go through and modifications of the batch and mini batch size. So you can go through and actually tinker around, and it will basically, this simulates like running SambaTune twice, and then you can, compare the reports together. Okay. Now we have one that is called an example of a model sweep. All right. So this is actually a sort of a newer feature into the SambaTune product. And what you can do here is you can go through and you can tell this, in this case, a model sweep. I want to go ahead and sweep through, the end features 256 through 1024 and 512 through 248. And it will go through and compile the applicable paths necessary to go through and test those iterations. And as it's going through and doing it, it will also go through and dump out a JSON file, which will tell you what it feels is the most optimal configuration of those combinations of features. All right. Now this is what is basically a Samba sweep. So here I'm keeping my model stuff the same, but the only thing I'm varying here is batch size. And I just want to see, what is my accuracy difference? What is my performance difference and everything as I vary through these different batch sizes? All right. So SambaTune run, and so basically when you run the SambaTune command, the available modes are run, which is a full training run. So if you do SambaTune run, you got to make sure you have obviously the RDUs available to you, or however many are required to run your model. If you go through and you issue this and you don't have those RDUs available, it obviously is going to fail, because it's not going to have the ability to go through and launch the model. Benchmark is how we get a lot of information on section times. Benchmark requires, Craig, I don't know if you touched on this in your presentation, but benchmark requires a measure performance section to be in your model. So when you looked at those Samba.session, the parameters for like the compile, there's also one of those that is called measure performance. And you need a measure performance section in your model to use the benchmark option. All right. Next is instrument, and this is allows us to basically build pests with some very fine-grained performance counters baked into them. Inherently, once you execute using these pests, because of the extra instrumentation, they're going to run a little slower, but it's not going to be problematically slower. But it will give you very, very good drill down on where you are spending your time and so on. And then the parameter sweep one. So if you utilize the compare or the Samba sweep, sorry, if you use the Samba sweep or the model sweep options inside your file, then you must provide the parameter sweep flag. Okay. And then the way you provide these flags are with like a hyphen in them. So here's just an example. Let's say I have my configs sitting underneath a folder called SambaTune configs. It's SambaTune configs pointing at the YAML file -m. Here I'm telling it to do benchmark instrument and run. And then if I look at here, my sweep command, linear Samba sweep YAML, and then I'm passing it the mode flag of parameter sweep. Sorry. Fairly self-explanatory. One thing that I didn't know until I actually tried this myself, you cannot combine parameter sweep with instrument, unfortunately. So, if you, let's say you're doing a parameter sweep and you pick out your best one, you run that best one, you're still not happy with it, then you can go through and do a standalone SambaTune on that best one, with the instrumentation flag turned on and get more data out of it. So you'll see here, SambaTune reports. So if you are not the type that loves a GUI, I'm going to go ahead and do something here real quick. I'm going to end the show. And too many monitors, bear with me. Okay. All right. So you see here, so this is under my linear Samba sweep run that I did. And you have your per section CSV files, your summary CSVs, your JSON files. So if you're the type that likes to write scripts and just chew on the data yourself versus looking at things through a GUI, all the background reports, CSV files and everything are here on the operating system underneath your SambaTune Gen folder. So you can see here when I was in NVMe Data Scratch Kobe A, when I set my artifact root to PWD, so it actually creates an artifact root folder, then under there SambaTune Gen, and every SambaTune that I run under that will then stack underneath that SambaTune Gen folder. All right. Oh, sorry. I guess I probably should stay there. All right. All right. So actually, no, sorry, I had clicked too far. All right. So the SambaTune UI. SambaTune UI is available as a flash HTTP server using Unicorn from the bare metal install, or it's installable as a wheel file for Linux and Mac. Right now, we provide those wheel files via the SambaNova Systems support cloud attached to a knowledge article. If you do not have access to that, we can work with Argonne to ensure that these wheel files get staged in a location where they are available to you. All right. As I said, right now, it only works on Linux and Mac. A Windows port is on the roadmap, as well as there is a Linux container port that is on the roadmap. So you just launch a container on your Windows environment and do that. Right now, the reason why it doesn't work on Windows right now is because Unicorn is not supported on Windows. So we have to port it to a different Flask web servicer. All right, so I'm going to go ahead and launch the command. Get that over here. Right here, you can see here, so SambaTune UI. I pointed at the directory that holds my SambaTune Gen. So basically, any of my SambaTune model runs that I've done that are underneath SambaTune Gen, I will be able to view inside the report, and then I pass it a port number. If you are running the SambaTune UI on a shared environment, please note that there is a chance that that port number could be taken if someone else is already running it. So often what I do when I talk to certain shops is if you are going to be running it from the actual DataScale system, I usually ask the IT admins to assign port numbers to individuals. So that way, anytime they want to run this, they have a particular port that they can utilize to do it. However, I will say it's probably easier for you to copy down the output out of the SambaTune Gen and, run it on your Mac or run it on a local Linux workstation, whatever you have available to you. When you run it, you can see here, it starts a Flask server. The username is always going to be admin, but you see this password here, it is always unique. It is generated fresh every time you run it, okay? I'm going to go ahead and get this. Over here. Get that to fit my screen there. There we go. All right, we're going to go ahead and refresh. That was from my last run of it. So if you kill your server and then bring it back up, then you got to go through it, relog back into it. So here I went through and I did a linear Samba sweep, and I did a linear apps run. So, and you can see here that right now I'm pointing to this path. Well, let's say I have SambaTune generations elsewhere. I can go through and change this path and click update and point it at a new path. New path, sorry. Let's go ahead and take a look at this one here. Go ahead and view. So here you can see the configuration that was utilized. By the way, is the font big enough on this for everybody? I'll take that as yes.
Yeah. Yes.
Okay. All right. So, it goes through the configurations, the parameters that were run from the YAML file show up in there. Your host information, just basically dumping out the host. You also get dynamic and static RDU information. We're not going to go through and drill down too much in all of this, but you could drill down in it. The static is obviously what hardware is available on the system. The dynamic will go through and say, okay, what was your hardware utilization, as far as some of your, DDR usage and things like that during the actual run. Okay, let's go back here to, now we're going to go to analytics on this one. And let's go ahead and go to review summary. So over here is our summary, and okay, I must have a problem with live demos. I must have a small little bug there in the latency calculation. But as you see here, as far as from the host, as you see here from the Pi instrument data, I can go through and look at my stack and see where I'm spending the bulk of my time. If I do find that I have an inordinate amount of time here, then I'll drop out of the system to utilizing standard profiling tools, perf, PyInstrument, C profile module, like that. And I did a parameter sweep. Why is it saying this? Okay. Anyway. Oh no, this is a compare, not a parameter sweep. Sorry about that. All right, so that was the host side. However, I did get information from the RDU side. All right. So these are the various sections of my model. These are the, the ones with the most, sorted by latency. I can also go through and select and see my PMU and PCU utilization, my DDR, to and from my DDR read and write. And I can get that information per section. Now, as far as what you're going to drill down in is, where you think, most of your bottleneck is. So let's see this one. So you see this is like around 120 gigabytes per second, DDR bandwidth read and write. These are a little bit lower. It might be interesting to look at these and say, okay, is there a reason why, am I not, stuffing enough data in the pipeline to satisfy these sections, or various different things like that? So I could go here, and these are the stages inside the section. I can go into the stage report and look, and basically when you get down into the analysis of this layer, this is when you're going to engage us. But we can go down there and try to see where your latencies might be. This one's right. PCIe. It's not bad, actually. Okay, so let's go back to the summary for a second. Let's go ahead and, this is the overall summary stage report. So these are the various different stages. I wonder if I can get the drill down that I wanted here. No, that's the lowest it can go. Oh, that's still in section 1. Here we go. Collated report. So this is the collated report, which we'll go through, and you can look at your measured latencies, and because that's all I have. So these actually didn't have any latency. So basically, the only latency that this actually measured is in this GBuff, which is basically a memory buffer copy operation. So this is another thing where you would then go through and contact support and say, okay, hey, I need to optimize. Is there any way for me to optimize this? Oftentimes, if you're seeing this as your largest latency, it's kind of expected, because you actually want most of your latency to be in your buffer operations. That means your model's humming along and you're just, streaming your data through there. You're just passing your data through. And then here it goes down into the various paths where the most lowest is. This is another one where you'll engage with SambaNova systems to go down there. And as you can see, all of the paths of latency are all in the internal buffer operations. All right, so now here's our this one here for the run, the transfer inference statistics. You only get this if you pass the run flag to your SambaTune model. If you don't pass the run, you're not going to get that information, because obviously you weren't doing any training, right? Training or inference. And here, why is it? And it just tells you the amount of time that you were executed on each tile. Huh. Okay, let's go ahead and look at the sweep one. All right, so here are my parameter sweep one. So you can see here, here's my section 0 latency based off of the batch size that I chose as I was sweeping through it. Here are my sweep throughputs based off of the settings that were done. Best size for, so you can go through and try to, you know, look and say, okay, which best size was really optimal? And, you know, in this particular case, I could be wrong, but it looks like 2 is winning most of the race here. All right, you actually get a parallel coordinate plot map specifically for section 0. This is pretty rad. So here's the configuration and basically your throughput measurements to go there. So obviously, okay, or actually it looks like it was actually 3 was the best batch size for this, as far, you know, somewhere between 2 and 3, best batch size for getting the best throughput. And I actually, and once again, live demo, I have to file a bug on this, that best config JSON file should be rendering here, and it is not rendering, and I do apologize for that. I will actually go ahead and get a JIRA ticket filed for that. So the TensorBoard and other tools on GPUs. Yes, that's actually what I was looking for. I'm not sure why I'm not seeing those right now, so that's why I got a little hesitant. One more second, let's go back in here again. Analytics, RDU. Okay, it did not run with the full instrumentation, so I don't have that on that one. Let me go back to here. Okay, when I go in here, I should have a little pop-up that actually brings that. So I have another little interesting undocumented feature here. Let me go back to the documentation, see if they actually have a picture of it there.
Kobe, we are coming up. We're out of time on the session. So.
Oh, we are? Okay. Anyway, I do apologize that for a couple little undocumented features there, but I will get the JIRA tickets file for those. I guess that's the hazard of a live demo. Thank you, everyone.